Okay, I want to talk about a few things, guys. One is I'm going to blast the misconception of twinkling stars and the redshifts and quasars. Traditional astronomy will tell you that the redshift of stars is indicating velocity, distance away from you. The more the redshift of a star, the farther away and the faster it's traveling away from you, which is complete bollocks, as those idiot Brits would say. What I told you before, guys, there are actually two levels of glass within the Earth. Two levels, okay? If this is the Earth here, okay, this thin line would be the glass sky at 100 kilometers. And then this line right here would be the celestial sphere glass, which is approximately maybe 2,400 miles away, up in the middle of the Earth. So you have the central octahedron in the middle here. You have a celestial ocean inside, the water's above, the water's below, so you have water below here in the ocean. And then you have the stars at the bottom of the ocean, and they're created by sonoluminescence. During the time of the flood, these sonoluminescent stars, they clustered together and they became very hot. And they began to melt through the glass celestial firmament and creating these little pockets, these little indentations and openings. The windows of heaven were opened, right? The windows of heaven were opened, and so the water came down. The water also came up from the fountains of the deep of the earth. So we had water coming down and water coming up. And so after the water came down and after the sand came down too, the sand is what created this secondary firmament at 100 kilometers, which actually pushed the water down. That's why we have the rainbow, because the sun is within this region here. So the sun is only a half sphere. Everything is operating on curved light. And so that's why we see rainbows, because the sun is being dispersed through this glass medium and being projected onto the raindrops. The raindrops are not the source of the rainbow. But anyway, going back to the celestial sphere glass sky, it healed back together. So it closed up. The windows of heaven were closed after the great flood. So now you have these indentations, these peaks and valleys. This glass celestial firmament, because of the way it had been ruptured, it had been opened up, and then it healed back together, it's not perfectly smooth like that. It's more like this glass here. Okay, you have these bumps all over it. That's why, okay, they call it, I'm not sure if I spelled this right, scintillation. Stellar scintillation, that's why they say stars twinkle. That's not, they say it's due to the atmosphere. They say that the atmosphere has different layers of density, and because we're viewing the stars through these different layers of density in the atmosphere, it will cause the stars to twinkle. However, we don't see the planets twinkling. Now, there's a reason why we don't see the planets twinkling, because the planets are not above this non-smooth celestial firmament. They are in the region of inner space where the sun is. So the planets are here. Okay? So we're not going to see the twinkling of the planets because they're not being viewed through this warped glass medium. Very simple, guys. Okay, so here's like a close-up of the crystalline celestial sphere, and you have these peaks and valleys in it, right? Okay. Redshift is very simple to understand. If you understand glass, if you understand light being dispersed through glass, it's creating the dispersion. It's creating the fringe effect. Okay, so if you're looking up through the celestial sphere, there's going to be a chromatic aberration going on, where the blues will appear to be closer, the fringe, and the reds will be appearing further away. And for the most part, generally, that's what's happening with the stars. Most of the stars we see with a higher redshift are further away, but they're not millions and billions of light years away. They're simply above the glass sky being affected by the chromatic aberration. However, there's some, see, this is where they can't understand where quasars fit into the equation, because quasars have a very high redshift. Very high redshift. Okay? And Hubble didn't realize this when he came up with the redshift theory. He didn't understand that there were quasars that were actually breaking the laws of redshift, of the so-called Doppler effect. That's simply not what's happening. If you understand that there are peaks and valleys in this glass sky, this celestial firmament, you can have a stellar object that is closer than a galaxy. Remember I said galaxies are just drains? They're drain remnants. And the drain remnants of what happened after the flood. After the windows of heaven were sealed back up, you have these spirals indicating drainage of the water coming down. So, and then after it healed up, of course, you have these this non-uniform surface now. It's a bumpy surface. And so, chromatic aberration in different areas of the sky will filter through these bumps and cause redshifts, even redshifts in objects that are even closer than galaxies. So there's a particular quasar that they just they can't understand where it's coming from, where the redshift, why it appears to be connected, because there's like this jet that's connected to this quasar at 7319 NGC 7319. Stupid camera. Get that fixed. So they can't understand where it's coming from. Why that quasar, which appears to be connected to that galaxy, has a higher redshift than the galaxy and the stars in the galaxy above. There's a much higher redshift. Okay, well, it's very simple. You're looking through this warped, non-uniform surface, and you're getting different refraction. You're getting different aberration, different fringe effects. That's all that's happening. Okay. And now also, keep in mind, when you see stars twinkle, they're mostly at the horizon. They're at the lower levels of the sky. So that's because you're getting your angle of incidence. You're viewing the stars through a more acute angle. So that's why you're seeing the twinkling happening, especially at the horizons. That's why planets don't twinkle. Now, let's say if you take the Hubble telescope above the atmosphere, you're going to see the stars not twinkling. Well, no. That to me, that is bullshit. Because they don't show any image. They just show imagery, still images of the Hubble. They don't show actual animated, moving twinkling of the stars. So that's what's going on here, guys. Twinkling is happening because these bumps in the celestial sphere are being viewed, are actually filtering the stars in which we see them. That's why planets don't twinkle. That's because they are not above the bumpy crystalline glass sphere. Okay, understand? So, modern cosmology is debunked. Stellar scintillation is debunked. See, the atmosphere is just it's very homogeneous. There's not all these weird turbulences like they say. The turbulence is coming, the so-called turbulence is coming from the glass, the two glass skies. That's where the turbulence is coming, the so-called turbulence. But it's really chromatic aberration. Good old chromatic aberration. That's why we get the redshifts. That's why we get higher levels of redshift in certain areas, even though it appears closer than their connected galaxies in these quasars, because of these bumps in the celestial firmament, which was damaged at the time of the flood. Bada bing.